So in this project, I'm currently doing, I want to do like a electric machine winding temperature estimation uh, using ML model. And I did a little bit research myself and found out that there is a public available data set on Kaggle provided by Peterborough University. So, and then afterwards, I found that there is some publication related to this data site that if I just read through here, I would say, there are a bunch of publications. So I just dragged one of the publication, essentially use it as an example to demo how to actually use AI tools for doing your research. I know, a lot of YouTuber has already um, covered this topic, but this is the first time that I do it by myself, so I think it would be useful for me to actually get it recorded, and maybe it could help someone in the future. So the first tool that I used is this connected paper. Essentially, what I did is I just paste that title in here. Then you can say that essentially it will search this paper. If you click on it, it's gonna show you a graph. And you see that our interested paper is here at the center or top. Uh, and this color actually shows how recent, the deeper the color shows, it is more recent publication. And these are some publication that in the past. Um, and then what makes it more interesting is that uh, it allows you to actually look at the um, derivative works, the paper that cited this paper, right? Um, so this is the first tool that introduced a lot to do research and find the prior works, derivative works, and see the graph that have essentially help you build up a knowledge that on such topic. Um, you know, you help you understand the current literature and history. So after I got this covered, I started looking at the AI tool that can help me read this paper, this specific paper efficiently. So what I did was I used something called ChatPDF. So it's kind of free to use. You can just uh, drop that specific paper here. And what makes it a very interesting is if you look at the historical question that I asked this um, chat, almost like a chat GPT, but it probably built on top of chat GPT. But what happened is that, you know, asked a bunch of questions in actually in Chinese, uh, but really you could actually translate this here in this window directly. Let's say please translate the following into English. So essentially, I have asked it, uh, you know, three questions. The first one is, what is the research question about this article? And the second question is, what is the research conclusion? The third question is what kind of argument and evidence does this article use to reach this conclusion? Uh, and I learned this from some Chinese YouTuber, but again, this is like the uh, level one reading technique that if you just want to crash the surface of this paper and kind of quickly get the key ideas, you ask this question to the Chat GPT or actually Chat PDF. So um, if I'm not asking it to translate, right, I just delete this and I just say please summarize um, the content of this article according to the following three questions and provide the article. Uh, so it's probably because I essentially it lost the memory because I have done this like maybe yesterday. Uh, but we can say that the article is estimating electric motor temperatures with deep residual machine learning, right? Um, let's say by Rohin in 2021. Okay, it says that here is a summary of that article based on our questions. So the article aims to evaluate the feasibility of using this neural network with the residual connections to predict latent high dynamic temperature continuously inside these permanent magnet motors without requiring domain expertise or whatever. So you could ask these kind of questions to any topic, not specific to the field that I'm currently researching. But that's kind of the first level question you could ask, and then you could quickly actually use another tool to summarize such um, content into uh, you know into a markdown language. You can say please use more concise words and make the answer compact. So it will sort of minimize the word it is trying to use, right? So we can say, can deep neural network with residual connections be used to predict electric motor temperature without requiring domain expertise and specific drivetrain specifications? That's a research question. And the conclusion is the deep neural networks with residual connections exhibit strong estimation performance at minimal model sizes and can be used as an alternative to classical thermal modeling of estimating electric motor temperatures. And we have this argument and evidence which were the authors used to use the test bench to collect temperature data and evaluated performance of these deep neural networks using an automated hyperparameter search and uh, manual merge of target estimators into multiple height architecture. They compare the performance of the deep neural networks with classic thermal model approach and found out the former can achieve comparable performance without requiring domain expertise and specific drivetrain specifications. So in my opinion, this is a very concise and good summary. So I could say, please um, convert um, the concise answer into Markdown format. Okay, so then it will write you essentially the Markdown format. What we could do is actually just copy this and go to another tool called Markdown Map GS.org, and then uh, Markmap. We essentially can just copy here of our Markdown language, but we might need to format it a little bit ourselves um, by just separate it into multiple lines, right? Um, okay, the author connects temperature data. Now, like it just created like a um, sort of like a um, map for you, right? Uh, so you can just download this as a HTML or kind of as a short summary of your reading notes. Short summary as your reading notes. So this is a very impressive technique that I learned from some internet source. Uh, and then what makes it more powerful is actually uh, this is almost like your personal research assistant. You can keep expanding and uh, ask it more specific questions like, for example, if you don't know what is this residual connection, right? You can say, what do you mean by the residual connections um, in your previous answer? So it will answer you um, that in the context of this article, residual connections refer to the element-wise addition of the activation at the inputs and the output of the layer or group layer within a neural network to a new output. This allows partial flowing information to take a shortcut and bypass a set of neural net layer, which can help to improve performance of the neural net by reducing the vanishing gradient problem and allowing for deep neural network to be trained. Um, the use of residual connections is a common um, technique in deep learning, particularly in the development of deep residual neural network. So if you still don't understand, you can see like give me a um, mathematical equation to explain it. So it will give you this mathematical equation that try to explain the residual connection. Uh, and if you are like a domain expert, right, you would notice that maybe this Y seems suspicious because it is saying that this is the output of the residual block, and then X is the input, Fx is the output after passing through one or more layers, Y is the final output, right? And then the addition of X and create a residual connection that allows the input. Uh, but you did not give equation for the residual, uh, right? Um, you can say like, sorry, you give the equation for the output, but where is the equation for the residual information? Right now, it provides you the residual equation is actually your input minus the output. Don't always trust what it is saying, but most of the time it gives you a very good answer, and you have to get it a little bit, challenge it just like you are challenging a real person, right? When you ask question to to the other person, he could initially misunderstood what you are trying to ask, and you just need to force it to give you the correct answer. So I can say I'm still a little bit confused. Right? Why is the uh, final output, which is only available um, on the final output layer, but how to compute uh, residual information for a hidden layer, right? So he it actually admit it made some mistake previously, um, and residual connection computed at each residual block, which is a hidden layer. The residual information is computed the difference between input of block and the output of block before addition of the input to the output. For residual block input, output, and final output Y, the residual information is computed as this. This residual information is then added back to so is Y the final output or the hidden layer output. I'm trying to compute residual information for this hidden layer. This now it tells you that this Y it is using is actually the intermediate output of that residual output. That hidden layer. Uh, where Z is the final output of block, right? So this from this you will kind of fully understand this concept. Um, there's really a lot of questions you can ask, like uh, what kind of tool did the paper use to train the model? Okay, so it will say that it used the TensorFlow and used the paper provided a link to the GitHub repository, which also contains the code to train and evaluate this machine learning model. And this code in the repository is implemented in Python and TensorFlow, including some script for data pre-processing, model training, model evaluation. This word doesn't explicitly mention the tool used to train the model. Likely that the model was trained by TensorFlow, as this is the framework to implement the approach. So you can see that this is really fascinating tool to actually help our research, right? And what makes it more amazing is that although we are talking about this paper, you could essentially ask any questions. Let's say I'm at work and I need to write a 16-bit counter using Verilog. You would ask, could you write uh, let's say 16-bit counter using, let's make it harder, VHDL for me. So it would kind of write you like a VHDL code that actually realize this 16-bit counter, right? It even explained to you a little bit on the syntax and logic. And uh, really, we could say that please write a test bench to test this 16-bit counter. Okay, so here it will write a test bench for you, and you essentially can plug those into the Xilinx Vivado and test it. I tested it and it works pretty well. This is fascinating. I used to learn these kind of things by myself, and it requires a lot of time to actually being able to efficiently writing VHDL, right? You could ask really how to best, uh, what's the best way to start learning VHDL. Sometimes if your question is too big, uh, the boat here might require a lot of time to search for answers. Mm, sometimes it might not give you a good answer if there is no single best answer for this, right? Well, let's say what it will say. I'm just kind of at this point making it up. Says learn VHDL can be challenging but rewarding experience. Here are some steps you can take to get started. Learn basics of the digital logic. Before diving into VHDL, it's important to have a solid understanding of digital logic concepts like logic gates, flip-flops, and state machines. The online resources available for um, you know learning this, including tutorial online resources, and then you learn the syntax and structure of VHDL, practice writing the code, use a simulation tool, and then build the project and join the online community. Um, you know, so this is fascinating actually. You could force it to, like, for example, you cite there are many online resources available for this. Could you give me some recommendations? Give you some, free online course offered by Georgia Tech on the EDX, where it covered all this Boolean algebra, whatever, and then the digital electronics is offered by MIT, and EDX covered some basics. I could really sit here and play with it the whole day. Okay, that's it for today, and I just want to kind of quickly show you what you can do with the AI, toolchain to help your research and help your learning in general and become more efficient.